Hey everybody, today we're going to go over the first section of the first unit of Algebra 1, which is going to be classifying of numbers. So it's basically just how we go about identifying numbers and what categories they belong to. So the first most basic number most people learn is the number 1, right? And number 1 is considered a natural number. Now natural numbers are counting numbers. So natural numbers go from 1 to 2 to 3 to 4 to 5, etc. And they go in that order, 1, 2, 3, 4, ascending, okay? So I'm going to go ahead and write this down here actually as well. So natural, also known as the counting numbers. Okay, that's going to be 1, 2, 3, 4, dot, 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 all the way to infinity. Okay, so natural is the first category. The second category, well, let's think of that. So we have 1, 2, 3, 4 on to forever. What's the next number somebody would learn going the other direction? It would be 0, right? So 0 is part of the whole numbers category. So whole numbers is all of the previous natural numbers as well as 0. That's the only number that is a whole number but is not a natural number. So you can think of the natural numbers are actually what we call a subset of the whole numbers because all of the natural numbers belong in the whole numbers. So this is where it gets a little confusing. So every natural number is also considered a whole number because you can see how it's placed within the circle, right? But not every whole number is a natural. It doesn't go vice versa. It doesn't go the same way because think about it. 0 is not a natural number, but it is a whole number. Okay, so we've gone 0, 1, 2, 3, 4, 5, and so on and so forth. Now let's keep going the other direction. So if we go this direction, if you're thinking of a number line, I say this direction, I mean the left of the number line, we're going to start going negative, right? So those are called integers. Okay? So integers are going to start at negative infinity. I'll write this here. Integers. So I'm going to have dot, 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 dot. Then negative 3, negative 2, negative 1, 0, 1, 2, 3, dot, dot, dot. So you can think of integers as the numbers that appear on a number line. So when you look at a number line in a classroom, most of them have negatives, 0, and positives, but there's something missing which we're going to get to. Now, all of these numbers are considered rational. Okay? Now, rational numbers are numbers that can be expressed as a fraction. So rational can be expressed as a fraction. So the reason we have this space outside here is because there are numbers that are rational that are not integers, they're not whole numbers, they're not natural numbers. It's also important to note that all whole numbers also are considered integers. So 0, 1, 2, 3, 4, 5, and so forth, those are all considered integers. But again, not all integers are considered whole numbers because the integers that are negative would not be considered whole, okay? I probably just thoroughly confused people, hopefully not. So let's think of some numbers that can be expressed as a fraction. 1/3, right? Or 25 hundredths, we could write as a decimal. Or, let's think of another one. 1/5, right? So these are all examples of rational numbers, and they don't belong in any of these other circles, but they are considered rational. Now there's still other numbers, though. We have numbers that are considered irrational, which sounds wild and crazy, right? So irrational numbers are basically things that cannot be expressed as a fraction. So rational, irrational. I always think I'm spelling this wrong. I don't know why that is. Irrational cannot be expressed as a fraction. Okay, so let's think of numbers that can't be expressed as a fraction. Usually one of the first ones people think of is pi, right? Because that is actually not a number that can be expressed as a fraction. It goes on forever with no discernible pattern, right? There's actually people out there that memorize as many spaces of pi as they can, which is kind of funny. I think I can think of better things to spend during my time. There's also some radicals. So for example, the square root of 3, right? Or radical 17, or radical 21, right? Or the cube root of 2, right? There's all sorts of interesting numbers that are considered irrational. They cannot be written as a fraction. However, don't fall for it. Just because you see a square root symbol does not mean it's... Ooh, sorry, the printer's going off. Doesn't mean it's irrational. So for example, we could have the square root of 4, and that would actually be considered a natural number because when you simplify it, it would be 2. But square roots are not necessarily going to be irrational. because you have to simplify it to see what you get. Now, all of these numbers are considered real, okay? The real number set. That's the 99.9% of the numbers you work with are going to be considered real numbers. This is what I get for recording in a copy room. So, anyway, I hope that clarifies it. This is basically all we need to know for classifying numbers. Let me zoom out a little bit here, okay? There'll be another video or two with some exercises in regards to this, but let me know if you have any questions. All right, thank you guys.